start today's class. So today we are going to solve some numericals. At first we are going to solve this numerical. So for solving this numerical we are going to choose an arbitrary interval, close interval a comma b, be any interval containing 0. Now let fn of x equal to what is given? Nx by 1 plus n squared x squared. Then limit n tending to infinity fn x equal to limit n tending to infinity nx by 1 plus n squared x squared equal to limit n tending to infinity x by 1 by n plus nx equal to 0 for all x belonging to closed interval a comma b. Now capital Mn equal to supremum where a less or equal to x less or equal to b mod of fn x minus fx equal to supremum of nx by 1 plus n squared x squared a less or equal to x less or equal to b. Now let we are going to choose gnx equal to nx by 1 plus n squared x squared for all x belonging to closed interval a comma b. Now we are going to differentiate it. G dash nx equal to n into 1 plus n squared x squared minus nx into 2nx by 1 plus n squared x squared whole squared equal to n plus n cube x squared minus 2, here it will be 2n squared x. So 2n cube x squared by 1 plus n squared x squared whole squared equal to n minus n cube x squared by equal to, we are going to choose n as common, so 1 minus n squared x squared by 1 plus n squared x squared whole squared. So g dash nx equal to 0 implies, what it will imply? N cannot be equal to 0, so 1 minus n squared x squared equal to 0. This implies x equal to plus minus 1 by n. Now what we already found? We found that g dash nx equal to n into 1 minus n squared x squared by 1 plus n squared x squared whole squared. Now we are going to find g double dash nx. This is equal to 2 n cube x into 1 plus n squared x squared whole square minus n into 1 minus n squared x squared into 2 into 1 plus n squared x squared into 2x by 1 plus n squared x squared whole to the power 4. Now this will be less than 0 when x equal to 1 by n and greater than 0 when x equal to minus 1 by n. So what will be the maximum value of g and x? Yes. So maximum value of g and x we got when x equal to 1 by n. So max g and x equal to 1 by 1 plus 1 equal to half. So capital Mn equal to half, which does not tend to 0 as n tends to infinity. Hence proved. Sorry, here 1 n square will be there. Now we are going to solve this numerical. So here it is given that mod of sin nx by n square, this will be less or equal to 1 by n square, and summation n equal to 1 to infinity 1 by n square, this is convergent. Being a which kind of series? Yes, P series with P greater than 1. Hence, by Weierstrass M test, what we can write? We can write that summation n equal to 1 to infinity sin nx by n squared converges uniformly and also absolutely for all x. And in case of cos nx by n square, the process is same. So that is your homework. Now for solving this question, at first we have to choose for any x greater than 0 m, that is arithmetic mean, of two numbers 1 by x and small n into x, where small n belongs to natural number set n is greater or equal to their GM, that is geometric mean, or 1 by x plus nx by 2 is greater or equal to root over of 1 by x into nx, or 1 plus nx squared by 2x is greater or equal to root over n, or 2x by 1 plus nx squared is less or equal to 1 by root n, or x by n into 1 plus nx square is less or equal to 1 by 2 into n to the power 3 by 2. Now even when x less than 0, mod of x by n into 1 plus nx square is less or equal to 1 by 2 into n to the power 3 by 2. Since 1 by n to the power 3 by 2 is a P series with P greater than 1 summation n equal to 1 to infinity x by n into 1 plus n into x squared. This is convergent on any interval. Now we are going to solve this numerical. So at x equal to 1, the series becomes, what the series becomes? Minus 1 plus half minus 1 by 3 plus 1 by 4 minus dot dot dot. And this is equal to minus is taken out as common, so 1 minus half plus 1 by 3 minus 1 by 4 plus dot 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 by Leibniz test. The series converges, but the series 1 plus half plus 1 by 3 plus 1 by 4 plus dot 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 does not, or you can directly write diverges, as it is a P series with P equal to, yes, 1, but mod of Snx minus Sx equal to mod of minus 1 to the power n plus 1 into x to the power n plus 1 by n plus 1 plus by n plus 2 plus dot dot dot. This is less or equal to x to the power n plus 1 by n plus 1. This is less or equal to 1 by n plus 1 for 0 less or equal to x less or equal to 1, and this will be less than epsilon for all n greater than n0. If n0 is equal to the integral part of one by epsilon minus 1. How we can find this? 1 by n plus 1, this is less than epsilon, or n plus 1, this is greater than 1 by epsilon, or n greater than 1 by epsilon minus 1. So, or you can directly write, hence proved. Now we are going to solve this numerical. So for solving this numerical, at first we see that each term of the series is continuous on closed interval 0, 1. Now Snx is equal to u1x plus u2x plus plus unx equal to 1 minus x into x within bracket 1 plus x square plus x cube plus So this is equal to 1 minus x into 1 minus x to the power n by 1 minus x equal to x into 1 minus x to the power n for x not equal to 1 equal to 0 for x equal to 1. Now Sx equal to limit n tending to infinity Snx. So this is equal to, from this what we get, x when 0 less or equal to x less than 1 and equal to 0 when x equal to 1. So this is discontinuous and thus it is not uniformly convergent, since it is discontinuous on closed interval 0, 1 is not uniformly convergent there. Now we are going to solve this numerical. So at first we are going to find integration 0 to 1 fn x dx equal to integration 0 to 1 nx into e to the power minus nx square dx equal to minus half into integration 0 to 1 e to the power minus nx square d of nx square equal to minus half into e to the power minus nx square 0 to 1 equal to minus half into e to the power minus n minus 1 equal to 1 minus 1 by e to the power n. So limit n tending to infinity integration 0 to 1 fn x dx, this will be equal to, limit n tending to infinity half into 1 minus 1 by e to the power n equal to half. Now limit n tending to infinity fn x, this is equal to limit n tending to infinity nx into e to the power minus nx square equal to limit n tending to infinity nx by e to the power minus nx square, and this is finally equal to 0. So integration 0 to 1 limit n tending to infinity fn x dx, this is equal to integration 0 to 1 0 dx equal to 0. Hence proved. Here it will be d of minus nx square. Now we are going to solve this numerical. So here f of x equal to limit intending to infinity fn of x equal to limit intending to infinity x by nx plus 1 equal to 0 for all x belonging to closed interval 0, 1. So, sequence f and x converges pointwise to f of x equal to 0 for all x belonging to closed interval 0, 1. Now, capital Mn equal to supremum of fn of x minus f of x, where 0 less or equal to x less or equal to 1. Now this is equal to supremum 0 less or equal to x less or equal to 1 mod of x by nx plus 1. Now let gn of x equal to x by nx plus 1 for all x belonging to closed interval 0, 1. So, g dash nx equal to 1 by nx plus 1 whole square here 1 into nx plus 1 minus x into n equal to 1 by nx plus 1 whole square greater than 0. So, g dash nx is strictly increasing on closed interval 0, 1. Also, gnx is continuous on closed interval 0, 1. Now, gnx assumes its maximum value. Where it will assume its maximum value? Yes, obviously at x equal to 1. So, capital Mn is equal to 1 by n plus 1 which tends to 0 as n tends to infinity. Thus, by Mn test, what we can say? We can say that sequence fn of x equal to x by nx plus 1 converges uniformly to f of x equal to 0 on 0 less or equal to x less or equal to 1. Hence, proved. Now we are going to solve this numerical. So here, let f of x equal to limit intending to infinity fn of x equal to limit intending to infinity nx into e to the power minus nx squared equal to limit intending to infinity nx by e to the power nx squared equal to 0. for all x belonging to 0, k. Now, capital A main equal to supremum of f n x minus f of x. 0 less or equal to x less or equal to k equal to supremum of nx e to the power minus nx squared minus 0. 0 less or equal to x less or equal to k equal to supremum of mod of nx e to the power minus nx squared. Now we are going to assume gnx. So gnx is equal to nx e to the power minus nx squared. Then g dash nx equal to n into e to the power minus nx squared minus 2 n squared x squared e to the power minus nx squared equal to n e to the power minus nx squared 1 minus 2 into n x squared. Now g dash nx, this is equal to 0, so this implies 1 minus 2n x squared equal to 0 because this term cannot be equal to 0 equal to plus minus 1 by root over 2n. G double dash nx is equal to minus n squared 2x e to the power minus nx squared minus 4 n squared x e to the power minus nx squared plus 4 n cube x cube e to the power minus nx squared equal to minus 6 n squared x e to the power minus nx squared plus 4n cube x cube e to the power minus nx squared. So this is less than 0 when x equal to 1 by root over 2n and greater than 0 when x equal to minus 1 by root over 2n. So gnx attains its maximum value at x equal to 1 by root over 2n. So max gnx, or you can directly write capital A main is equal to n into 1 by root over 2n e to the power minus n into 1 by 2n equal to root n by e, which tends to infinity as n tends to infinity. Hence, proved. Now we are going to solve this numerical. So here Snx equal to nth partial sum of the series equal to S1x plus s2x plus dot 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 plus snx equal to x into e to the power minus x square minus 0 plus 2x e to the power minus 2x square minus x e to the power minus x square plus dot 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 plus nx e to the power minus nx square minus n minus 1 x e to the power minus n minus 1 x square. And this is finally equal to nx e to the power minus nx square. The series Snx converges pointwise or uniformly on converges uniformly to Sx on closed interval 0, 1 if and only if the sequence of functions, that is sequence converges pointwise or uniformly on closed interval 0, 1. The next part is same as previous questions. Solution. So that's it for today. We are going to meet in the next class. Till then, bye.